Hi there, my name is Miss Townsend, and I love math. Welcome to Math with Townsend. All right, well, this video is for grade 10 students who are studying quadratic relations. Well, anyone who's studying quadratic relations, I guess. Um, it's a video on word problems in which no equation is provided, so therefore you have to create the equation based on the information. And from a worksheet that I've handed out to my students, it's question number 5. Let's have a look at the question. It says a rectangle is 24 centimeters long and 16 centimeters wide. When each dimension is increased by the same amount, the area is doubled. What are the new dimensions? Okay, so let's think about the situation and then we'll start to formally solve. So we start with a rectangle. Oh, let's actually make that, we might as well center it, you know. So we start with a rectangle and it's 24 centimeters by 16 centimeters. And then we increase each dimension. So we make the length longer and we make the width wider. So we're going to increase to a new rectangle. And each dimension is increased by the same amount and the area will be doubled. What are the new dimensions? So if the area is doubled, we can actually do that pretty quickly because we know the area of the original rectangle will be 24 by 16, which means we can do that calculation and we can find the new area. Okay, so all we have to worry about to start with is how are we going to define a variable? Let's look again. Now, what I always recommend is you read the last sentence. What are the new dimensions? So you could let x be the new length and let y be the new width, but this is one of those times where that's not the simplest method, and it's actually could be quite confusing. We know that each dimension is increased by the same amount. In fact, the only thing we don't know is what that amount is. Are they going to be increased by 10 centimeters, by 100 centimeters? We know everything else. We know the original area, we know the original length, the original width, and so on. So the only unknown is right here. How much do I increase them by? So that's where our variable comes from. So we're going to let x be the amount, by which the dimensions are increased. Oops. And of course, we're going to say in centimeters because that's the measurement unit. So x is the amount by which the dimensions are increased. Therefore, what is the new length? So the original length was 24, but I have to increase it by x units. So the new length is 24 plus x. And the new width is, well, 16 plus that amount. So I have an area with a length. So now I have a rectangle that has a length of 24 plus x and a width of 16 plus x. And I know that the area is twice the old area. Well, the old area was 24 by 16. So therefore, the new area is just 2 times 24 times 16, which is, handy dandy calculator nearby, 768. So here's this rectangle. It has a length of 24 plus x. It has a width of 16 plus x. And now we know it has an area of 768. So if we turn that into an equation, we should be able to solve. So area equals length times width. And therefore, 768 equals length times width. So there I have one equation with a single unknown called x. And now I can go ahead and do the math required to solve for x. So I need to do some FOIL over here so that I can start rearranging and putting things into proper format. So multiplying the first together, 24 times 16. And then the outsides together. Oops, sorry, that's not right. A little math boo-boo. Everyone does. So this should be 384. So then 24 times x, 16 times x, and x times x. So let's write everything in the proper order. So 768 equals x squared plus, that would be 40x plus 384. And finally, I need to make it equal 0, so we're going to subtract 768 from both sides. So when I subtract 768, I get negative 384. So here's my equation. So I have an equation. It's a simple trinomial, and I need to solve for x. So we could try factoring, certainly. In fact, let's go ahead and try factoring. I just am in the mood. Feel free to go ahead on your paper right now to do the quadratic formula, and you'll see we'll get the same answer. I don't even know if this is factorable, but let's look at it. So all the things that multiply to 384. So, and I'm looking for negative 384, so I need the difference. So these two numbers, 1 and 384, would have a difference of 383, so that's no good. Again, I'm looking for a difference of 40. And I'm just doing this to remind you how to find factors if you're really not familiar with some of the numbers. 2 and 192 would have a difference of 190. That's not what I want. 3, and so in my calculator, I'm just doing division. And 128 would have a difference of 125. Again, I'm looking for 40. 4 and 81 would have a difference of 77. That's not what I want. 5 doesn't work. 6, let's try 6. 384 divided by 6 is 64. The difference between those numbers is 58. Still not what I want. I doubt 7 will work, but let's give it a shot. So 384 divided by 7. Nope, that doesn't work. Let's try 8. 384 divided by 8 is 48. Ooh, now, these two numbers multiply to give me 384. And if I make this positive and this negative, they also add to positive 40. Perfect. So this was factorable. Yay! What a good review of factoring that was. So this is a simple trinomial, and it factors into x plus 48 and x minus 8. And again, that's because if I now do FOIL, I would do x times x is x squared. Negative 8x plus 48x is that middle term, and 48 times negative 8 is this. So, I mean, maybe it would have been faster to use a quadratic formula, but there's enough videos I've made where you've seen me do that, and not a lot of videos anymore where I factor. So, good review. So again, now I have two things multiplied together to equal 0. So if this thing equals 0, I don't care what this is, I have a true statement. Or if this thing equals 0, it doesn't matter what's here, I have a true statement. So what would make this bracket 0? Let's find out. If x was negative 48, the first bracket is 0, and I have a solution. So there's one of my roots, or answers for x. Here, if this bracket is 0, so what makes that bracket 0? The number 8. So there's another root. So I have two potential answers for x. Let's go up and review what x is. X is the amount by which the dimensions are increased. Uh-oh. Can you increase a measurement by negative 48? No, especially not when those measurements start off at 24 and 16. So even though the math is correct, we put one line through it and we call it inadmissible. Again, it doesn't mean it's wrong. We've made no errors. It just means that it's not allowable, or it's not possible to answer the question with that answer. So that leaves us with x equals 8. So if x is 8, remember what we're trying to do is find the new dimensions. So if x is 8, we can say, therefore, the new length is 24 plus 8. Oops, is. And the new width would be 16 plus 8. And again, before I walk away from this question, I'm going to make sure I'm right. If I multiply 32 times 24, do I get double the previous area? So 32 times 24 is indeed 768. Excellent. So hopefully not so bad a question. And that's the end of this video, and maybe I'll see you at the next one. Ciao.